Good morning, everyone. Welcome to the session, Creating Data-Driven Cloud-Native Ecosystem at the BMW Group. So my name is Junjie Tan. I'm the Principal Consultant from AWS Professional Services. My specialty is Big Data and DevOps. I'm based in Munich with beautiful mountains and lakes with water. So together with me are BMW colleagues, Josef Vierhauser and Simon Kohn. Ken? So sorry. Josef is a product owner of Cloud Data Hub, and he has very strong data scientist background, and he designs the overall architecture and defines the roadmap for Cloud Data Hub. When it comes to automation and data lake as code, Simon is an absolute expert. So we will start with the mega trends in auto industry. So the first one is connectivity. So connected vehicle is more closer than we can imagine. So from the powertrain, ADAS, to the connected service and the smart interiors, a car becomes more connected both internally and externally. So the car makers offer you options when you can order connected service on demand, like autonomous driving. A car as marketplace. From the comfort of your car, you can have the access of the whole list of contextual, local, location-based services like food ordering and payments, hotel reservation, and even the offer from your preferred dealership. Electrification. So electric cars are charged and ready to go. There are more than 270 startups on the market which reveal the electric industry. So electrification becomes more pervasive in the ride-sharing and micro-mobility solutions. Autonomous driving. So an autonomous driving car has a lot of sensors on the car installed, like cameras, radars, and lidars. A car can produce up to 25 terabytes per day. So that is a huge amount of data. Subscriptions. So the car makers are becoming software and service companies. So they could eventually simply make the car for the user subscription. So the mega trends in the automotive industries are creating huge amounts of data. We need more intelligent insight and decisions based on AI and ML on top of this data. So to store and analyze the data, AWS provides a broad profile of storage and analytics services. So when we talk about data lakes, we talk about the three main features. So the first one is the single point of truth. From R&D, manufacturing, logistic, to after sales. So all these departments could work on the same data lake without moving the data around. So we actually encourage our customers to democratize the data usage in their enterprise. The second point is supporting of various data formats, from rational to non-rational data. It could be car sensor data. It could be also images from autonomous driving. The third option is that scaling the storage and compute individually. We could put our data into S3. We can easily scale out to petabyte-sized workloads. We can use different tools for data analytics and machine learning, like Asina, EMR, or Glue. So we have learned a lot of features are launched from SageMaker yesterday. They are like features like SageMaker Studio and SageMaker Notebooks. So we are very excited to try it out. So overall, the data lake improves the efficiency and effectiveness of the enterprise. So I'm very happy to hand over to Josef to give you a great BMW example.
Thank you, Junjie. So I'll actually now have the honor to talk a little bit about how BMW actually tackled the whole cloudification of its data lake. We'll structure the residual parts of the presentation as follows. So we'll actually have a first walkthrough through the BMW Group IT. I think that's going to be important for you to understand how BMW is set up in terms of its global organization. We'll actually then cover a couple of points of the motivation of why the BMW Group decided to actually move towards a cloud-based data lake. I'll then actually outline a couple of major aspects of what is the design about that. We'll actually give a demo. It's the first time we're giving that demo today after having spent probably 7 to 8 months now from staffing the first person that was working on the Cloud Data Hub from where we are today. And I think this is really exciting to give you a quick demo of what the system looks like. Then actually Simon will come on stage and talk a little bit about architecture. So he's going to provide you a very, very deep dive into how the architecture is set up, of how Kinesis, Athena, Glue, all these kind of technologies that Chunji mentioned before are being used at a massive scale. As a heads up, we are processing 10 terabytes of data on a daily basis within Kinesis, Lambda, the streaming processing pipeline. Simon will tell us somewhat more exciting news than I can actually do right now. We'll then actually wrap up with design decisions and lessons learned. Let me actually start with a video because I think that perfectly shows how innovative BMW Group IT is actually driving forward the radical change in the organization.
BMW introduces your BMW Intelligent Personal Assistant, the soul of your BMW.
Hello, BMW. How do I activate the High Beam Assistant?
He is there when things don't go your way.
Hey BMW, I just want to relax.
If you like, you can give him a name. It will be his personal activation word.
Hey Joy.
Hello BMW, turn on executive mode please.
Whatever the situation, whatever your mood, you can simply feel at ease.
Hi BMW, activate expressive mode.
Or let the fun begin. This is your BMW Intelligent Personal Assistant, the revolution of driving pleasure, always by your side.
I think that this is really a great example that shows how BMW is driving customer engagement. And I think at the heart of all of this, there are complex IT systems that make sure that we can actually personalize the experience that you have within a car. This was an offering that we launched late 2018. Now it's getting more and more connected. It's getting more and more personalized and contextualized, such that we are able to understand at which kind of context to use certain functions. I think this has been a great example. We have many, many more examples. So we do not only focus on customer-driven innovation, but also on more traditional parts of the company. Ultimately, we are producing cars. So there's like a whole set of complex processes that make sure that the car is produced in time. So manufacturing, logistics, customer service, after sales. These are all very, very interesting parts and important parts within the organization. So we got to make sure that by using data, we're actually improving both efficiency and effectiveness for these kind of processes as well. So as a heads up, as we are talking a lot about vehicle telemetry, vehicle sensor data, because evidently that's fancy shit. Simon will actually talk a lot about that. We also have more traditional data sources that we still have to interface when we talk about data lake. Let's start out with some facts about the BMW Group IT. So in total, we actually have, as part of the BMW Group, the IT has 5,000 employees worldwide. We are headquartered in Munich, Bavaria, where you can find lots of good beers. We have a substantial overseas footprint in the US. We have, most prominently, we have offices in Greenville, Woodcliff Lake, and in Mountain View. So we have the tech office in Mountain View. In 2018, we actually have instantiated a joint venture in Portugal. Our joint venture, Critical TechWorks, that has been built up with critical software in Portugal, based out of Porto and Lisbon, is helping us to even more aggressively drive the adoption of the DevOps culture within IT. For example, also we feature a shared service center in South Africa, very important for us for many of the more traditional kinds of systems, speaking about the SAP shared service center. And we have evidently a large footprint for a very important market, China, with offices in Beijing and Shanghai, and also in Singapore, actually, in APAC. A couple of facts and figures I think that's always interesting to look at. As a multinational and multicultural organization, we have 60 nationalities working in roughly 30 countries with us. We are currently in the midst of our agile transformation. and we organize ourselves along IT products. So it's really, IT projects are things of the past. We are moving towards, adopting an IT product culture with proper lifecycle management. Today, actually, our infrastructure connects more than 500 locations worldwide. So the locations that I've shown before, this is only IT locations. We have many, many more locations, micro locations that we connect here as well. I think last but not least, today we are processing 1 billion requests from more than 12 million vehicles. We were among the first movers actually in 2003, I believe, to introduce BMW Connected Drive. So we had a long history, resulting also in a heterogeneous landscape that is now getting more and more transformed while moving towards cloud. Simon and me, we are part of BMW Group's data transformation group. Our mission is simple yet complex. So our mission is to transform BMW into a truly data-driven company. This journey is actually fueled by a lot of technological innovations, and it is ultimately driven by three things. It's driven by data and AI, it's driven by cloud stack, and it's driven by emerging tech. Let me start with the first one, which is actually very important for us, that for any kind of analytical workloads, we want to make sure that data is actually required and must be there in the highest quality only possible. Otherwise, you will actually fail to support certain use cases. Accordingly, also organizational structures must be set up. So things like data scientists, data engineering roles, data stewards that take care that we have that end-to-end lineage of when data is actually being generated within the cars on board and when they make their way actually to our backends. I think that's super important that you actually outline of how this can actually work in a big enterprise. I think we've actually underestimated that when we started in 2014, that the whole organization must believe in data, not only a couple of IT folks that are sitting somewhere. And I think that has been one of the major learnings that we moved forward in 2019. Moreover, I think we need to have a strong emphasis on tooling and providing the right tools and frameworks for data scientists, citizen data scientists, to actually work with the data in the most effective ways, which is ultimately why leveraging a good cloud stack that helps you move that forward is quintessential. Ultimately, we see that a competing cloud stack is a prerequisite to make all of that happen. And data usage, data provisioning, it must be as easy as working with Excel ultimately in our end vision. A modern cloud-native data stack actually helps us to move more and more away from the heterogeneous landscape that we found at the end of 2018. And our partner in crime here is actually AWS. Thanks again, Chunji, for all the support from professional services here to move that forward so aggressively in such a short amount of time. And given the maturity, the breadth, the depth, and we've seen Andy Chess's keynote yesterday, I think with a lot of services, we actually are moving very aggressively within the organization to make sure that people actually have the right tools to work with. Lastly, we also believe, speaking about emerging tech, that novel and sometimes unproven technologies, speaking about things like, for example, natural language processing, that has made its way kind of into many of the organizations. Distributed ledger technology, speaking about blockchain, all this stuff, and also quantum computing, which is a little bit more further down the road. They are already influencing the choices that we make today of our platform. So I think that's really, ultimately we want to see, we want to actually steer through our data journey with open eyes and open minds and adapt and adjust and expand upon the vision that we currently have very quickly. Now let's talk a little bit about what was driving us towards adopting cloud in that aggressive fashion in 2019. We started actually with our big data journey in 2014. I was getting part of the company only in 2015, actually 2016, sorry. And back then in 2014, we soon adopted a stack that was fairly traditional. So we adopted Hadoop, we adopted Kafka. So we were basically fueling our data transformation on top of the Hadoop ecosystem. Soon actually things like, for example, Kafka came into play for any kinds of streaming workloads. Evidently, BMW already back then, we had a huge streaming data background, so data from cars that has been streamed out was already existing back then in 2014. And vehicle and other device data, for example, as well as traditional data sources, like, for example, ERPs, CRM systems, other kind of OLTP databases. We actually ingested these data sources either via Kafka and Spark or via more traditional ways. Back then it was Kube for us. And everybody was kind of happy, only kind of, but to be frank, in retrospective, nobody really was, because most of the requirements that people had, that our customers had, we could not actually fulfill these with the rigid stack that we had that consisted out of Hive, HBase, and the problem was ultimately that people soon actually, and that's the second step here, began to introduce purpose-built databases to speed up their workloads. So people introduced Postgres, but we've seen much more diverse databases being introduced. Speaking about Teradata, Exadata, we have all sorts of databases at BMW, believe me. And ultimately, this was due to the fact that we, based on the data stack, we could not satisfy all the customer requirements that we had. And ultimately, what we ended up having is a heterogeneous, multi-project, and ultimately also hard to scale landscape. Lastly, we wanted to harness the results of our analysis. So speaking about machine learning, model hosting, speaking about hosting web frontends that would actually deal with data. So yet again, the Hadoop ecosystem was not the right choice, the right fit for us for these kind of workloads. So what we did is we introduced in 2016, 2017, we introduced a Kubernetes cluster that would actually take care of hosting models and making sure that we were dealing with these kind of requirements. And if you reflect the kind of stack that we've been building up, it was ultimately, in one word, it was heterogeneous, hard to scale. The results were 4 points. First point, only fractions of the critical organization's data were able to be ingested. Second point is bottlenecks were quickly visible, so you had these kind of central teams. The notion of central teams was very much visible in the organization. So you had central teams taking care of data ingestion because it was from experts, for experts, it was hard to scale. It was no self-service whatsoever. And we were not able to actually overcome this by simply throwing people at the problem. Third point is our data scientists and our BI folks, they actually soon moved towards purpose-built sandboxes. Like, for example, they were spinning up their Jupyter and Zeppelin notebooks. They were basing their data science experiments on top of things like, for example, Docker that would help them guaranteeing reproducible data science experiments. Others, they actually moved back to their old and existing things like, for example, Tableau and ClickSense for the more traditional BI part. So ultimately, what we had, and that's now the last punchline of this slide, the number of prototypes that we had spinning out in whatever kinds of sandbox environments that people were developing was actually orthogonal to the number of things that we actually brought into production. That was the bad thing actually back then, which actually led us towards adopting cloud in one sentence. And looking at the stack in our old world and prior to the reign of the Cloud Data Hub, which is the AWS built upon data lake at BMW, we heavily depended on a big DevOps team to be able to operate all the things that I've aforementioned. And to be clear, the whole DevOps team, it had full end-to-end responsibility over all the components here. As a result of that, we only had very limited amounts of time to actually be able to spend with building up the differentiating bits and pieces that you can actually see here. So focusing on use cases, focusing on providing the data at the right quality in time, was not in focus. It was really like, making sure that the Kafka cluster would actually get the new box within the next 2 weeks of time. Using a methodology referred to as a lift, think, and shift, where we re-architected major parts of the platform and said, we do not want to take this beast that we have on premises now and re-instantiate this on the cloud platform. We actually started to move major parts into AWS and primarily built upon cloud-native building blocks and fully based upon infrastructure as code. Simon will certainly talk more about that, of how that looks like in practice. This enabled us actually 2 things. First one is we operate the Cloud Data Hub in a shared responsibility model with AWS ProServe, but also with AWS as the platform provider. Secondly, yet again, we can actually focus on the more differentiating bits and pieces and want to, for sure, make sure that we avoid any kind of undifferentiated heavy lifting. So really, focusing on making sure that we have the right quality of data in our systems. Moreover, we have had and still have a couple of hypotheses that are very important and that support the move towards cloud. First of all, we'll not be able to keep up with the radical pace of innovation that AWS has in their data lake services portfolio. Our time, for sure, that's the second one, is better dedicated in making sure that we understand, curate, transform, and leverage our very specific BMW data as opposed to doing something else. Now, enough to talk about these high-level details and about the bad old world. Let's now move on to the actual platform design of the Cloud Data Hub built upon AWS. Premises were threefold. First of all, we wanted to enable a very quick infrastructure setup in different regions. We wanted to be inter-region while also maintaining high security standards and complying with regulations. Second point was we wanted to support a quick data integration for a wide array of data sets, both streaming and relational related. And lastly, we wanted to provide consistent means of actually how people will interact with the data and how we manage identities across the platform. So speaking about single sign-on, I think many of the organizations that adopt AWS, GCP, Azure, one of the first challenges is not building up the data lake, but one of the first challenges is making sure that it plugs well into the enterprise scenarios. So we actually chose a layered approach that consisted of three major layers. First of all, it's the real-time zone, which basically keeps cached copies of real-world objects, like, for example, the vehicle, our customers, for fast access of non-historicized data that is needed for example, for inference of machine learning models. Then we have the insight zone. The insight zone keeps the historicized versions of the real-time objects, but it also makes sure that it deals well and it plays well with the already existing relational databases. I mean, you got to acknowledge as a big enterprise that there are going to be a lot of data warehouses that have already been built up. There are going to be a lot of OLTP systems that you have to interface. So better make sure to acknowledge that role as well. And the third point is unified API, which is not solely a collection of RESTful APIs that makes the interaction of people with or of systems with data easy, but it gives us the ability to expose both real-time data and relational data very effectively to customers that will actually deal with that data. Three things were important moving forward here with the data platform. First of all, we wanted to enable a setup that would let us actually democratize the data usage within the organization. So as we can see it here, we wanted to provide easy access to data for both bounded and unbounded data. We wanted to enable a single point of truth for any kind of data analytics and discovery, so everybody should find his relevant bits and pieces of data inside of the platform. And we wanted to enable data stewards to intuitively actually look at what's already there. And I think one of the bigger buzzwords that we actually have embarked on over the last couple of years was the idea of introducing a data catalog. To be honest, we've looked at a lot of external providers supplying this capability, but ultimately we were not happy, which is why we built up something on top of the existing Cloud Data Hub, which would actually allow us this kind of exploration. I'll actually show that later on. The second point is modularity. So what we wanted to make sure is that people can actually interact with the building blocks in a modular fashion. They can actually take certain bits and pieces if they want to do data ingestion. They can also bring their own building blocks if they want to. And ultimately, it's really key to enable a broader community to work with your platform. I think what we've seen over the last few years was also the point that often we have been building up a system from experts for experts, and if you do not convince a broader set of the organization to have a big buy-in into the platform, I think it's a bad sign. The last point is lean ops. We built around state-of-the-art cloud native services, which really would enable us to move towards a state where AWS and us together would actually maintain major parts of the platform, truly drive forward also this lean ops vision, because ultimately what we wanted to avoid is that we put in a lot of effort and energy into making sure that our system is being kept up running. And the last point here is we rather wanted to deploy something too early and fail fast in order to be able to adapt quickly afterwards. I think many of the requirements in the data space, they are very heterogeneous. Sometimes people do not know what they want, especially if you talk about data catalog. If I talk with you individually, I would actually get many different opinions, many different requirements, depending on your role that you have within the organization. And I think that's really a fair point where you actually got to say, let's bring out a version 1 based on a couple of hypotheses and then make sure to iterate fast. Now enough to talk. I'm actually hereby introducing our portal, data.bmw.cloud. So it's actually providing you with three things. It's providing you with the option to explore data. As you can see it here, it brings a nice SQL Explorer such that data is really at your fingertips. Everybody within the organization is able to dive into data very quickly. The second one is it makes providing and consuming data fairly easy. And the third one is you can actually manage that data across individual identities within the platform. So it makes sure that people that interact with the data, they interact with a safe and governed way, while still maintaining the speed that you need for these kind of platforms. Let me actually walk you through a live demo. So we're making some videos here to give you an indication of how that looks like. And this is now the exploration part. So what Patrick does here, he actually logs in with his BMW internal number. He makes sure that he logs on here to the system by using a second factor. He checks which kind of roles he has. So here, for example, what we introduced is the notion of hats, so people can put on different hats. He's now here in the role of the connected vehicle engineer. And he can actually go further and pull up the data explorer. So what the data explorer does, technically, he connects against the Glue data catalog, but he abstracts away because, I mean, many of the users within the organization will not understand anything about cryptic database names and cryptic table names. People want to have something that they can interact with in a natural fashion. And our API actually takes care of that. So every kind of resource that is provisioned within the Cloud Data Hub, it will be provisioned by actually providing certain context on top of the existing S3 buckets, Glue data catalog items, and so on and so forth. What Patrick is doing now, he's actually querying the extended floating car data. So this is one of the most prominent data sources at BMW, and it collects anonymized, fully anonymized data in a GDPR compliant way. So he's actually now querying the session ID, he's querying the longitude and latitude, sorry for the resolution, and he's gonna go ahead and save that query. And that's, by the way, that's something that we have on prod. It's nothing fake, so I can actually show you afterwards to prove it. We have a lot where we want to actually develop further, so our vision is to actually enable a broader community to work with all these great tools that we have here. The second point I wanted to show you is how you actually provide data. What we've seen with the legacy stack that we've been building over the last couple of years is that providing data is always very difficult. So there is no one-size-fits-all tool. You can look at manifold ETL tools, maybe Informatica, Talent. On paper, they will solve every problem, but as soon as you begin to introduce that, you will hit certain limitations and bottlenecks. And ultimately, what we wanted to do is two things. First of all, we wanted to make sure that people have easy means if they are already acquainted with the AWS world. Like, for example, if I understand IAM, if I understand Terraform, I can actually already go ahead and build upon existing Terraform templates. But if I'm not, then here's what we actually do for you. So you actually go here. Again, in the role of somebody that wants to bring data, you go to the data ingest tab. You will configure the ingestion. That is, by the way, based on CDK, on the Cloud Development Kit, that would actually interact with CloudFormation and make sure that the stack is being orchestrated. You make sure that you provision your glue job in that case in the right VPC. So I think he chose public here. We put in the database credentials. That's going to be a Postgres database with a certain database name, with the port and the database credentials, and that's basically all of it. And the stack takes care of that. So as soon as we actually create submit, create ingest, the CDK stack is being orchestrated in the background. You can even actually schedule that. So it's not a one-off operation where people can actually bring their data and then that's it. It's really something that you can schedule. It works on top of Glue ETL, based on Spark, based on PySpark. And you can actually do all of this scheduling, which is pretty powerful. So I haven't seen that with many other organizations. I think many of the organizations actually thinking around introducing these kind of capabilities into their teams. But I think it has always been complex. Speaking about the older world where AWS only had EMR, and EMR was a pretty heavyweight. So this really is a good example of how we use managed services to make all of that happen. And the stack behind all of that is basically Lambda that takes care that CDK is being transformed to CloudFormation, and then all is being orchestrated on top of managed services. Lastly, we've also thought about how can you actually consume data in a neat way. And what we've received from many of our consumers is that they actually wanted to build up something that is based on Spark. So many of the data analytics points, they actually start with Spark. And we wanted to overcome the situation where people build up their own walls. So what we are doing here is we give the user the ability to actually spin up a SageMaker stack. So soon it's going to be the SageMaker IDE that we actually spin up here. You can size your SageMaker instance here. As you can see, within the dropdown, you can actually say, I want to have a certain dimension of that SageMaker notebook setup. But what you can do here, and that's pretty interesting, is because SageMaker for many types of analysis that we have for terabytes of data, it's not really sufficient. So we actually provision an EMR, Elastic MapReduce cluster with it that you can actually perfectly size here as well. The next steps forward, so you can actually open a notebook, you're right in there. The kernels are bootstrapped, so you can actually directly interact with EMR based out of your Jupyter notebook. And that's pretty exciting for us to move that forward. I think there are a couple of extensions that will come later on next year, especially in Q1 and Q2. Like, for example, making sure that also, not so business-savvy users are actually able to tap into data quickly. But I think it shows at least, it indicates at least of the path that we are going towards. So let me invite Simon on stage.
Thanks, Joseph. When we look at the data sources that we are ingesting into the Cloud Data Hub, there are really two fundamental types. So there is unbounded data, which is streaming data that has low latency requirements and needs high throughput. We're tackling unbounded data with Kinesis and Lambda, so the managed services from AWS, and build modules and templates around that to make it really easy for our data providers to ingest data. Same on the other side, so for bounded data, which is more the traditional data sources like relational databases or also file ingests, we created modules so that you can schedule your batch jobs or do one-off jobs with the help of Glue ETL or EMR. So for both of these types of data, we have various data sources throughout the company. And it is really scattered throughout all the domains of the company, like vehicle development, customer data, and so on. So we really needed a way to democratize these data workloads. So we came up with architecture where we have multiple data providers on the left side and multiple data consumers on the right side. And in the middle, we have our Cloud Data Hub. So what we do there in the middle is we store all the unbounded and bounded data, build our tools on top of that. So the portal that Joseph showed before, where we have the Data Explorer, the SQL Lab, the AI Lab to start SageMaker, and really give a good user experience to our customers. And on top of that, we have an API to provision resources inside the Cloud Data Hub, and also building a community around the Cloud Data Hub with docs and talks channel and so on. So to make it really easy for our data providers to bring data, we built modules, as I said. So for example, the ingest of relational databases that Joseph showed in the portal is also possible via a Terraform module, where you basically give the same data as Joseph showed in the UI. You provide the database details, you provide a schedule when the database should be imported into the Cloud Data Hub, and you can define what kinds of tables you want to ingest. And this makes it really easy for our data providers to bring their own data into the Cloud Data Hub. And this is also really customizable, so you can modify the PySpark job if you want, build in your own transformations, and this is really set up through infrastructure as code. So on the next slide, we see what is actually provisioned inside the data provider account when you run that Terraform module. And you see here that we really leverage the managed services of AWS. So we have our Glue ETL job in the middle in the data provider that is triggered by a Glue trigger, and it uses all the AWS services around Glue. So CloudWatch, for example, for logging in metrics, Secrets Manager for the database secrets, and then the local Glue data catalog to store all the metadata. This Glue ETL job is deployed in a private VPC, so we have access to our on-premises databases. Inside the Cloud Data Hub, there are really only the two resources, so the source S3 bucket, where the ingested data is stored, and the global Glue data catalog, where all the metadata is stored and made available to consumer accounts. And both of these resources are triggered or created by our API, so a data provider, when he wants to provide new data to the Cloud Data Hub, he just uses the API to create those two resources, and then he's good to go and can build his own infrastructure in the data provider account. Yeah, the same modules we've built also for unbounded data sources, so streaming pipelines, and we use some micro batching in there based on serverless components. So we have Kinesis as our streaming service. We use Firehose to batch it to S3, use Lambda to transform the data, and have also Fargate in place for importing legacy Kafka topics into Kinesis. With that flexible infrastructure, as Joseph said, we import more than 10 terabytes per day in that streaming infrastructure, and we really integrate seamlessly with the on-premise Kafka and also with newer services that are natively built on AWS, which provide the data directly in Kinesis streams. And as before, for the relational data ingest, you really, as a data provider, can modify that pipeline to your needs, so build your own transformations, but you have the templates in place to get started quickly. So when we look into the provisioned infrastructure for unbounded data, we see a little bit more than on Glue. So we have on the left side our Fargate container in the private VPC that has connectivity to our on-premise Kafka, for example, and that Fargate container pulls the data from Kafka and writes it to Kinesis. From there on, we use Firehose to batch it on the source S3 bucket, and through Firehose transformers, we mask some PII data to be as safe on GDPR side. From there on, we trigger the processing via S3 events. So every time a new file is written into the source S3 bucket, an S3 event is triggered. That event is written to SNS, and through this SNS topic, providers and also consumers can subscribe to that and do the later processing of that file. So in this example, we have a prepared layer. So we have the notion of layers, the source layer, prepared layer, and semantic layer, where we, with every layer, we enrich the data further for our consumer accounts. In this example, we have a prepared Lambda that reads the data on the source S3 bucket, does some transformations, and writes it into the prepared S3 bucket. It also makes sure that all the metadata is in the local Glue data catalog, and with that, we can make sure that the Glue data catalog sync is picking up that metadata and is written into the global Glue data catalog. As I said, this gives us a really easy and flexible way to ingest streaming data sources, and even though we use micro-batching, we have for most of our data sources an end-to-end latency between 1 or 2 minutes. From writing the data into the source Kinesis stream until the data is visible in Athena. As Joseph said, we have a very big multi-region footprint, and we also have that when enriching data. For example, vehicle master data is mostly available in our Munich data centers. So when we want to enrich streaming data with that master data, we have to make sure that it is available in every region globally. So in this example, we use the vehicle master data, and every time when new data is put in that bucket, we trigger our cache loading Lambda. That Lambda pulls the data from S3 and then writes it into a DynamoDB table. And that table is replicated across multiple regions with DynamoDB global table. So in every region where we do the preparation steps, we have the data in place that we need. So when we built up our infrastructure with that multiple accounts, we also faced some difficulties with S3. So in our example, you've seen that we have the data provider, and that is writing into the core Cloud Data Hub account, and data consumers are reading the data from that S3 bucket. So we use S3 bucket policies to control access, so which customer has access to an S3 bucket, but those policies apply only to objects that are owned by the bucket owner. But when we use the data provider to write data into that bucket, the objects that are written are actually owned by the provider. So we can't give access to that files to consumer accounts. To get around that, we have two different approaches. So for services like Glue, which support role switching, we switch actually the role to a core Cloud Data Hub role before putting the data into the source S3 bucket. So for Glue ETL, we use an EMRFS credential provider that we've made, that we've written, and this makes sure that we have the right object owner in place in the source S3 bucket. For services that are not role-aware, we use another workaround. So for example, Firehouse cannot switch role before writing files to S3. We actually intercept the S3 event before giving it out to our consumer or provider accounts. And we use a so-called fixed ownership Lambda to change the ownership of the object. And after that, forward that S3 event again to our consumers and our providers. So as you've seen, we've done a lot this year, but there is more to come on the provider and core account side. So what we really want to do is make sure that we provide streaming data with lower latency, for example, introducing technologies like Kinesis data analytics to have more real-time processing of unbounded data. Because as I've said, so we achieve 1 to 2 minutes latency from source to target, but for some applications, that's not enough. Another point where we want to focus on is improving metadata handling. For example, for some use cases, it is very important to track the data lineage from source to semantic layer. And at the moment, in our API, we have no way to express what kind of transformations we did from source to semantic, but that's also something that we want to add. And also regarding metadata, we want to make sure that consumers of our data can have a good search through the metadata and also some indexing inside the data. So if you want to find some vehicle telemetry data, that you really get a quick way how to know in which database is what data. And the other point is that we want to further improve the customer experience with, on one side, more building blocks. For example, for one data provider, we made Elasticsearch available with a Terraform module, and this is something we want to build out more for other data providers and consumers so they get started quickly. And in addition to that, we want to add more features to our self-service portal so that all the modules that are available through Terraform are also available on a more easily basis via the UI. So now you've seen what we did on the provider side, but the actually interesting thing is what is going on the consumer side. So this is really where our data scientists and analysts use the consumer accounts for advanced analytics. And services like SageMaker are really important. We are really looking forward to the services that were announced yesterday to make it available to our data scientists. They can provision EMR in the portal, as Joseph showed before, which is really important for them. And they can use QuickSight in there. So basically all the tools that AWS provide can be used in the consumer accounts. And this is something that is really important in our design, that data providers and data consumers have really the freedom to design their own custom infrastructure. We always provide building blocks and templates, but when they have a special use case, they can always use the power of AWS with all the different services to really build what is needed in their use case. They can even, in the consumer account, use the SNS topic to trigger their processing when new data arrives, for example. They have actually built some use cases already. What we really have as an advantage is that we have data sets from all the different departments throughout BMW, so that we can enable, for example, a 360-degree customer view with the vehicle telemetry data, with CRM data, with master data, to really make get a better understanding of our customer behavior. A second point is like crowd data analytics, where we source data from our connected vehicle fleet and really get to know how people are using our vehicles and can make we can make use of the data throughout our vehicle development process. And what you see here on the right is our AI-based fleet management for mobility services. So this is a tool for car sharing to really get the demand of our customers together with our supply of vehicles so that we can steer our fleet in the right direction. And this is something that we built also with the technologies of the Cloud Data Hub. Okay, I think Joseph will give us a wrap-up of our lessons learned that we made so far.
Thank you, Simon. So I'll actually now start to wrap up as we approach the end of the session. Let me actually cover a brief wrap up here. So I think the most important things that you see here is that we have a couple of related sessions from BMW. The first one, it has already taken place on Monday and Tuesday. It was about serverless GraphQL architectures where Patrick showed how we actually use AWS AppSync for workloads. That's super interesting, so I recommend that you actually look that up afterwards and see the session. The second one is BLC 209 asset provenance ledger based on Amazon QLDB. That's something that my colleagues Andre and Emil are going to talk about from the blockchain group. And there's another blockchain talk, BLC 203, why you need a ledger database. I think reflecting now on the presentation, thanks Chunji and Simon for joining me today. We've made a big journey in 2019, going from on-premises Hadoop to something that we have today that we just presented. I think there was an exciting journey with many ups and downs, frankly. And ultimately, we've seen the major capabilities that we've been introducing, and this was only possible due to the fact that we built this stuff with AWS, with the help of AWS Professional Services as well, based on the broadest and actually deepest portfolio that helps really BMW scale out data usage within the company. Ultimately, if we actually see how QuickSight, SageMaker, all these technologies, including the high-level services like, for example, Comprehend, Forecast, Amazon Lex evolve over time, I think it's really great if you think about the number of use cases that you can build out. There are many more, hopefully many more to come, so I'm actually looking forward to what will Werner Vogels tell us tomorrow. I'm hoping for some Athena and lake formation stuff to happen there. So actually also looking forward to plug in lake formation into our architecture. It frankly has not happened yet because we lacked the multi-account compatibility of lake formation with our setup here. We are a heavy customer of Athena. Athena, 2 weeks ago, sharing with you, they've introduced the federated query capabilities. So I think Athena is evolving more and more for us as the single point of truth for any kinds of data analytics for analytics within the organization. Because it's great if you can not only do queries on top of S3, but also if you can federate queries to whatever database you can think of. Yeah, let's see how that actually evolves. I think Elasticsearch Service is another interesting aspect to talk about. So Andy Chassie introduced Ultra-Warm yesterday. Let's see how that evolves, but I think there are going to be exciting things upcoming in terms of Athena and Elasticsearch. We already today, Simon hasn't told you about, have quite a big Elasticsearch instance that takes care of certain bits and pieces of vehicle telemetry data. So I think making sure that you have this kind of hot, warm, cold storage tiering for your analytics workloads is also exciting going forward. I think having said all of that, we will actually invite you to the area level 3 Ironwood foyer for the automotive and manufacturing lounge. It's the speakers lounge, so we'll actually stick around. We'll not answer questions for now, so you can actually, we'll take questions off the stage. And having said all of that, I thank you all for your participation today. It was an honor to have us, hopefully. And yeah, thank you.